All right, so here we have just this, I don't want to say a blank unit circle, right? But this is what we call the unit circle. What that means, why is it called the unit circle? The prefix uni means 1, right? So basically, this is the point 1 comma 0, right? We don't need to put that on there, but that's the point 1 comma 0. This here is the point 0 comma 1. This is the point negative 1 comma 0. And of course, 0 comma negative 1, which is that guy. Okay. What do these numbers represent? These are the measures of this central angle, right? So for example, if I were to draw this, I'll just outline this in blue, for example, right? In standard position, this is the initial side. This is the terminal side, right? Then this angle right here would have a measure of pi over 6 radians, which is the same as 30 degrees, okay? So what we want to do then is determine this coordinate, right? What is this coordinate here? Okay. Now remember what that means is, that means we are trying to find the distance of this x value and this y value over here, right? You got to be very careful. We know, right? You see it outlined in blue here? We actually know this length, right? This length is actually 1 because every radius in the circle has a measure of 1. So from the center to here, that's 1. From here to here is also 1, right? What we're trying to find is this distance, right? So I'm going to do this in red here. So we want to find this x value and this y value. And that'll be whatever coordinate this is, right? This x and this y. So actually what we want to do is we actually want to do that for every single point here. Okay? Or we're not going to do them for all the points, right? We'll just do them for a few. Okay? So wait a minute. How do we determine what this x and y value is then? Okay? There's a couple ways to do this. And the way I'm going to do it is I'm going to use the idea of these special right triangles, right? So for example, we know that this angle is 30 degrees. And this angle, of course, has to be 60 because this angle is 90, right? See this triangle that I drew right here? I'm just drawing it again. We also know that this length here is 1. Okay, now, what is the relationship in a 30, 60, 90 right triangle, right? We know that the side opposite the 30-degree angle is always half of the hypotenuse. Okay, so this just comes from, I don't want to say high school geometry, right? But this length here, the side opposite the 30-degree angle, is always half of the hypotenuse. So if the hypotenuse has a length of 1 here, then this length must be 1/2. And also in the 30, 60, 90-degree right triangle, the side opposite the 60-degree angle is always radical 3 times the shortest side. So this is going to be 1/2 times radical 3, which is radical 3 over 2. So this is the x coordinate, the y coordinate. That's this, right? This is radical 3 over 2, and this is going to be 1/2. Okay. And hopefully you realize, well, I don't really have to do that for all of these, right? I can, well, we'll look at that in a little bit. Okay, what about this one here? This pi over 4, right? So I don't want it to get a little bit too messy, so I'll just do this. Right? But we can certainly draw the triangle that extends to pi over 4 here, right? And we see that pi over 4 is 45 degrees. This is a right angle, of course. This has to be 45 degrees as well. And once again, the hypotenuse is 1. Okay? So it turns out the relationship in a 45, 45, 90 right triangle, okay, it turns out that this is always going to be radical 2 times whatever this length is, right? So this length here is actually going to be 1 over radical 2, okay? Which if we rationalize that becomes radical 2 over 2. Okay? So that means that this coordinate here is going to be radical 2 over 2, comma, radical 2 over 2. Now here's where we got to get a little bit creative, right? Let's think about this carefully. Here we have this, right? In this case, this is 60 degrees, right? So I'm going to draw the 60 degrees here, the 30 degrees here, right? We know once again that this is 1, but hey, wait a minute. I also know that the side opposite the 30-degree angle is always half of the hypotenuse. So this should be 1/2. This should be radical 3 over 2. And oh, wait a minute, yeah. That means that this guy here should be 1/2, comma, rad 3 over 2. So these are the values in the first quadrant. But if you look at the second quadrant, we'll realize, hey, wait a minute. This angle here, right? This angle here looks like it's in the sort of the same position, except it's just in the second quadrant, right? Not the first quadrant. So we can actually use these guys to determine actually the other 9 values. The only thing that will change, right? If you think of this very carefully, these 6 numbers will not change. The only thing that will change is the sign based on which quadrant we are in.